Hi, we're going to spend the next few minutes talking about what fourth grade students in College Station ISD will be doing in their math classes during the first 9 weeks. This is actually the second part of 2 videos for the first 9 weeks. So if you missed the first part, you might look for that video so you can get a complete idea of what your child will be doing this 9 weeks. So here's kind of our roadmap. The students will start out understanding and applying whole numbers. That's what we talked about in part 1 video. And in this video, we're going to talk about understanding and applying decimal numbers, as well as representing fractions and finding equivalent fractions. So they're going to represent decimals, including tenths and hundredths, using concrete and visual models and money. For instance, they might have to figure out in which amount of money does the digit 8 represent 8 cents. And there are actually 2 there in the list, $4.78 and $5.38. Susan paid $2.62 for 5 stamps. What is the value of the digit 6 in this number? So they would, there's a picture to help them visualize what $2.62 or 2 62 looks like. And then they would probably write down that number in standard form. And then they would see that the value of the digit 6 is actually 6/10 because the 6 is in the tenths place. They're going to compare and order decimals using concrete and visual models to the hundredths. So when that says using concrete and visual models, that means that they're always going to have either some manipulatives that represent these decimals so that they can move around, or there's going to be some pictures there that they can look at to help them understand, because decimals is a very new topic for fourth graders. This is the first year that they've talked about and represented decimals. And so we're using lots of visual models, lots of concrete models, so that they can really see and understand what they're talking about. Here are a couple of questions that might come up. The decimal 82 hundredths can be shaded on the grid below. And so they might go ahead and shade that in. Which grid is shaded to represent a decimal less than 82 hundredths? So here they're comparing the one that represents 82 hundredths and trying to compare it to the others and find one that represents less than that. The question to the right of that is the distance in meters that 4 students jumped are modeled below. So we see that Marisol jumped 1 63 of a meter. Benito jumped 1 5/10 of a meter. Otis jumped 1 4/10 of a meter. And Angie jumped 1 46/100 of a meter. So when we're working with students, a lot of times if they see a picture like that, we're going to ask them to label each picture, to write the decimal number next to each picture, and then they're going to put those in order from greatest to least. And you know, when they're working on these problems, it's really important to label things, as I've already mentioned. It's also really important to read very carefully and critically. If a student just scanned that, a lot of times they're going to confuse the fact that they are supposed to find these in order from greatest to least, and they might put it in the reverse order, starting with the least and going to the greatest. So it's really important that they slow down, they read critically and carefully, and make sure that they understand what they are being asked to do. Because even though it's asking from greatest to least and that answer choice is down there, the answer choice where they reverse it and go from least to greatest is always going to be there also. So if they don't read carefully, they're going to choose that wrong answer. They're also going to determine the corresponding decimal to the tenths and hundredths place of a specified point on a number line. So they have the number lines, and for instance, on the first question, they're asked which point represents 66 hundredths on the number line. And so they would be, if they're using good test taking strategies and good critical reading strategies, they're probably going to go through and label what decimal is represented by point J, which decimal is represented by point F, which one is represented by H and G, and then go back and look at the question and make sure they know which one answers the question that they've been asked. The question on the right asks which number line shows a point plotted at 8/10. So they get 4 different number lines there, and again they should find the point on each number line and label it. What point is represented by the point on this number line? And do that for each number line until they find the one that represents 8/10. They're also going to be asked to add and subtract decimals to the hundredths place using the standard algorithm. Jody made a poster for the school picnic. The uppercase letters that Jody used were 4 25/100ths of an inch tall. The lowercase letters that Jody used were 2 5/10 inches tall. How much taller were the uppercase letters than the lowercase letters? So they are comparing these two heights and they're going to subtract, but the important thing to notice is that the first number in the problem goes to the hundredths place. There are 2 numbers after the decimal point, and the second number only goes to the tenths place. There's only 1 digit after the decimal point. And so we work on making sure that they understand that they need to line up the decimal point before they do any addition or subtraction. And we also often encourage them, if one number has fewer numbers after the decimal than another number, they could fill in with a 0. So they, instead of writing 2 5/10, they could write 2 50/100ths, because that's the same value. But maybe it makes it a little bit easier for them to do the addition or the subtraction. They also relate decimals to fractions that name tenths and hundredths. The model below is shaded to represent 2 62/100ths, and then we have the model there for them to see it. So in the beginning part, the number is represented as a mixed number with a fraction. Then they're asked, which decimal does the model represent? So they have to take the same number that they've already seen written as a mixed number with a fraction, and now they have to take that same number and write it as a decimal. The question on the right asks, the model below is shaded to show the portion of 2 walls that have been painted. And then there's a model that shows 1 8/10. Which fraction and decimal represent the part of these 2 walls that have been painted? So they look at the model, they have to decide how to write that as a mixed number with a fraction, and also how to write that same number as a decimal. So they need to understand that we can take anything that we write as a decimal and also write it as a fraction, a mixed number. They're also going to be asked to determine if 2 given fractions are equivalent using a variety of methods. Jessica baked cookies for her soccer team. She placed chocolate chips in 10/12 of the cookies. Which fraction is equivalent to 10/12? And on the original question, there were answer choices, but they can find a fraction that's equivalent to 10/12 by dividing the numerator and the denominator by 2. And then they would arrive at 5/6 and know that 10/12 is equivalent to 5/6. They also will have instances where instead of dividing the numerator and denominator, they might multiply the numerator and the denominator and find an equivalent fraction. They could also use this picture to help them determine an equivalent fraction by circling cookies and making, instead of having it divided into 12 different items, they could group 2 cookies together and have 6 sets in here. They're going to compare 2 fractions with different numerators and different denominators and represent the comparison using the symbols greater than, less than, or equals. Which of the following correctly compares the shaded parts of the fractions below? And again, before they start, I would really encourage the students to label each of these pictures, to label that one represents 2/8 and to represent and label that the other one represents 1/4. And then they're going to start looking down at the comparisons. 2/8 is less than 3/4. So they have to look at that. And first of all, neither of the fractions are shaded to represent 3/4. So they're going to throw that one out. Then 2/8 is equal or equivalent to 1/4. And they can use what they know about finding equivalent fractions as well as the pictures to help them decide that that is the correct answer. And then they're going to look at the other two comparisons and again use what they know about equivalent fractions, use the pictures that are provided to them, and determine that those H and J are not true. They compare two fractions with different numerators and denominators, but they're not always given a picture. Forest Glen had their first track meet of the year. Jan ran 6/8 of a mile and Ann ran 2/4 of a mile. Which of these girls ran the greatest distance? And so they can use what they know about finding equivalent fractions and get these fractions so that they have the same denominator, making it easier to compare. Or they can also reason through it. The fact that 6/8 is greater than 1/2 because 4/8 is 1/2 and 6/8 is greater than that. And the fact that 2/4 is equivalent to 1/2. So 6/8 is greater than 1/2 of a mile and 2/4 is exactly 1/2 of a mile. So we know that Jan ran the greatest distance. So they have multiple strategies to do calculations, to reason through it. So if your child needs some extra practice in some of these topics, you can go to this website and you will find online resources. And if you click on any of the tiles that pop up, there are a long list of tiles with different math topics. And if you click on a topic, then it will pop up with a page that has several different websites where your child could have quality practice with that particular math topic. If you go all the way down to word problems, there is a website called Thinking Blocks, and that is a really, really good site to practice. So thank you for listening. There will be a new set of videos, a new playlist of videos at the beginning of each 9 weeks. And after you watch that, after you watch the videos, if you still have questions or need some more clarification, be sure to contact your child's teacher or the math specialist on your campus. If you go to this website, you will find a page that lists all of the math specialists in the district and which campus they're on. So you could also contact the math specialist from your campus with an email or a phone call, and they would also be glad to talk to you. So again, thank you for listening and have fun learning math with your child.